Good morning, everybody. I'm Giovanni Paolini, and today I will show you our progress for the project Wildfire Emission Explorer, which is a challenge of the ECMWF Summer of Weather Code. But before diving into the details, I wanted to present our team. I am an aerospace engineer, currently doing a PhD in remote sensing in a company called ESoWC together with the University of Lleida in Spain. And I know she's a mechanical engineer specialized in human factors and currently covering the role of product owner at Nijstay, Netherlands, and before also working as a UX UI designer in the same company. About the challenge, the general goal is to create an application that can retrieve a subset both in spatially and temporally of the big data set the ECMWF produced of wildfire emission. The dataset is the Global Fire Assimilation System from ECMWF, and it is delivered daily at 0.1 degrees from 2003 until the present. It uses MODI's Terra and Aqua active fire products to assimilate in the GFAS. This dataset is then used from us to then extract a subset of data and visualize them in real time. To do this, we mainly used Python with these different packages. For visualization, we based our project on a Jupyter notebook compiled with Voila so that it could be used as a web interface. And inside some packages used for visualization are also leaflet and Python widgets and IPython leaflet together with matplotlib for the final plots. For in the background, and then for processing, we used PostGIS to store all the data in the database and to query them, and then pandas and GeoPandas in Python to organize these queries and to visualize them. This is a prototype of well, now I will redirect you to the prototype that we've been developing and the state at this moment. So there are different steps that the user is asked to do in order to finally retrieve the data from the dataset. First, is asked to retrieve a subset, a spatial subset, so to do a geographical selection of the area of interest globally. So you can choose from the different countries that are here selected when I hover on top of them, or to directly write the continent of the country of interest. For example, here in South America, I will select the South American area. Then there are also other interaction buttons that we developed. For example, we could draw a rectangle or a polygon or the two of them together to select an area and then combine them with also different countries. And finally merge all of them together in a final area of interest. This area of interest can then be downloaded to be reused on a second time with this upload button. So we developed some interface to make it easy to reproduce the same work more than once. Then after the geographical selection, in this case we choose a wide area in Europe, we move into temporal selection of the specific period we want to analyze. In this case, I selected the month of June of this year, with a daily resolution. It could also be monthly in this, and with aggregation, with a special aggregation sum. So it will sum all the data inside the area of interest. Then as an optional choice, it's also possible to select a reference period to compare it with our period of interest to see what is the trend and what are the changes. In this case, since the dataset starts in 2003, I selected all the years until 2021. And then we can have a look at all the variables that it's possible to query from the dataset. Usually the most used one is the wildfire radiative power. So here I select it. And finally, there are some plots that could be produced from this GUI, like line, bars, and 2D visualization and also animation. For example, bar plot will create both a visualization at daily scale of all the emission in the area of interest, sum them up together. So here is extracting the data for the specific period, the reference period, and now we finished. And here you can see what are in red the emission of the month of June of this year and in gray of the previous years. We can also download this data into CSV, and we will have the same numbers that we see here. So this is for the bar plot. It's also possible to create lines, and in this case it will extract it again. Pressing the same plot, it will create it. Also 2D visualization, where we see the area that we selected and the distribution of the wildfires, and also an animation. And here you see it's extracting data for all the days in June 2022, and it's possible to see the evolution of the fires in the area. So, and it's also possible to download the data daily for these plots to be able to reproduce them. So finally, after creating this GUI, we were able to have a first validation of the way we create this visualization. And to do this, we used the latest press release from ECMWF, where there is some data depicted for Alaska and for the latest wildfires in the month of June. And here you can see that the specific period of June of this year compared to the month of June of the previous years has a much higher value in terms of total fire radiative power. So we wanted to see if we were also able to reproduce this data, and we used the GUI to select the area of interest and the time period. And we finally created this bar plot, which has the same values as the previous one, and 2D visualization and the animation, where you can see that late in the month the wildfires are increasing sharply in the area, everywhere in Alaska. So this is the point we reach at the moment. We want to continue to add more plots and more and to make it easier for the interaction in the GUI, but this is already a working prototype, so we wanted to show you how it's being developed at the moment. If you have any question, I think our mentors can very well address them. I couldn't connect today, me nor Ainhoa, but we will be there for the final presentation days. So thank you again, and see you in September.